Assalamualaikum warahmatullahi wabarakatuh. We are from EC1105D and I would like to present about our mini project ECG 353. So our group members are Muhammad Irfan Anik bin Arazul, Muhammad Amir bin Muhammad Bahari, Muhammad Syamin bin Muhammad Shukran, and Muhammad Kashaf bin Ilyas. So for the introduction of this mini project, we are need to construct a water tank and using the data from the borehole test. So the borehole tests are having many types, which are standard penetration test, trial exit test, Macintosh probe test, and more. So what is borehole? Borehole is a hole that dig and bore through the ground. Borehole tests also can be constructed to determine the type of soil and bring out the underground water to the storage tank. So the underground water will flow through many channels for daily routines. Many the underground water can use for many purpose. Next, we move to the soil analysis data. So these are the borehole data that we use to make our assignment. So the test, the data showing that the soil at borehole 2, which is borehole test 1, are dense and the undrained shear strength is increasing from 120 kN per meter square to 200 kN per meter square. So uh, most of the type of soil at borehole test 1 are silt. And then for the borehole test 2, which we take borehole 5, so the type of soil at the borehole 5 are silt and the relative density are dense. So the undrained shear strength are also increasing from 173.5 kN per meter square to 200 kN per meter square. So we take this data because the borehole tests are construct from the first meter to the 10th meter. So this is our soil profile. We separate it for borehole test 1 and borehole test 2 and find the soil profile before we construct our water tank. So after we get the soil profile, we manage to construct our water tank at borehole test 1, which means also borehole 2, as the soil are more dense than borehole test 2. So this is our water tank prototype. So we make it from the recycled materials that we have. So for the vertical stress distribution, as I say, the higher the from the first meter to 10 meter, the vertical stress distribution are decreasing linearly. So the first meter it starting from 99.8 kilonewton per meter, and at the 10th meter it will be 26.5 kilonewton per meter. For the justification, I would like to say the silt are different from clay, even though the silt and clay have the same characteristic, which are dry and in powder form. But the higher the silt liquid limit, the higher the compression the silt can resist. And then the soil stress decreasing through the soil, we can calculate using the simple vertical stress, which in this mini project we use circular load. The soil stress being distributed by the ground movement and the effective strength is manipulated by the changing of strength and the changing of volume. So next, the water tank that we propose are suitable to construct at this site because with the water tank size are 10 meter diameter and 5 meter height. The second layer of the soil can resist up to 94.9 kN per meter square, and the soil can hold up until the third layer to construct the water tank. The soil are suitable to resist the proposed water tank. That's all from us. Thank you.